Question 10 and 11. We have been breaking these up one at a time, but we can throw these together. Actually, it helps, I think. So, for question 10. Mr. Hawkins pushed a 9.3 kilogram black box across the floor with a net force of 96 newtons. What was the acceleration of the box during that push? So we have the mass of the box, and we have the net force that the box was feeling. So we're going to use that same equation we looked at just a second ago. Force is equal to mass times acceleration, but we're looking for acceleration, so we'll get our a by itself by just dividing both sides by m. And then we can plug in those numbers. 96 newtons divided by 9.3 kilograms for a grand total of we'll round it to 10.32 meters per second squared. That's our acceleration. Now, what about question 11? What would a free body force diagram look like for the black box during the push? So let's remember, any free body diagram will start with just a simple box. And then we need to include all of the forces, not just the forces that the question talks about. So it does talk about a force of a push. It also doesn't tell us which direction the push is coming from, so we're free to pick a direction. I'm going to pick it's going right. So that's force of, I'll say force of push. Now, if I'm pushing a box along the floor, there's going to be some resistance. We can't forget about friction. So we also have some force going to the left. All that force of friction. Now you'll notice that these are not the same lengths. That's intentional. Since our box is accelerating towards the right, this force must be stronger than the force that's opposing it. All right, but what about the other forces? Well, we're certainly going to be on Earth, so we have force of gravity. And since the question doesn't say that the box is accelerating down or through the floor, we can assume something's canceling out that force of gravity, and that will be our normal force. Now, ideally, these should be about the same length, but it looks like I drew this one a little off, a little too short. So one thing I can do, common trick for these sort of things, is to draw a little line there and a line there. That tells the person looking at the picture that these are supposed to be the same length. Whereas we can say this one has 2 lines, so that's its own length. This one has 3 lines, so that's its own length. These two have the same number of lines, so they should be the same length, they're the same strength. Now for this question, I will warn you, on the final exam, or the semester exam, there's no way to draw on the Google form that you'll be filling out for the exam. So for this, you'll just type out into words what this free body diagram would look like. So a way to describe this, we could say there's a strong force of push going towards the right, there's a weaker force of friction going to the left, and there's force of gravity going down and normal force going up. The force of gravity and normal force have the same amount of force, so they cancel each other out. That would be a perfect way to describe what this free body diagram should look like.